Okay, in this section, we're going to be talking about relations and functions. And a relation is actually short for relationship. A relation is any set of ordered pairs. And what I mean by an ordered pair, we remember like 2, 3 is an ordered pair to where 2 is an x value and 3 is a y value. Now, we call these relations because a relation, again, shows a relationship between the x's and the y's. Now, relations can be shown in different ways. We can show a relation. It says a set of ordered pairs can be shown in a table, a mapping, a graph, or we can also express it as an equation. And we will look at each of these in just a second. The set of x values is called the domain. That's all the x values. And the x values are the inputs in a function. It's the values that are going in. If we put in a 2, we get a 3. The 3 would be the output. The set of all the outputs or the set of all the y values is called the range. A relation with distinct points is called discrete. And a relation with connected lines or curves is called continuous. And let's take a look at what we mean by that. If your relation is, okay, this x has this y, this x has this y, if you just have dots here, there, and everywhere, that's called a discrete relation. Or if it's a continuous connected a line or curve, that's called a continuous. Okay, let's talk about what a function is. A relation, it's a type of relation in which each element of the domain, so each x value is paired with exactly one, and that exactly one is so important element of the range. So we have a set to where each x is paired with only one y. So 2 is paired with 3, 3 is paired with 5. This is just an example. 5 is paired with 9. 6 is also paired with 9. But notice if I ask you, what is 2 paired with? It's 3 and only 3. What is 3 paired with? 5 and only 5. What is 5 paired with? 9 and only 9. What is 6 paired with? 9. Now, let's take a look at something that is not a function. Let's say 2 is paired with 3, 5 is paired with maybe 7, and 2 is paired with 6, would not be a function. And here's why. If I ask you, what is 2 paired with? Well, 2 is paired with 3 and 6. So therefore, that forces to not be a function. If there's any x that's paired with multiple y values, because in order to be a function, again, each x is paired with exactly one y. Okay, a vertical line test is a way to see if something is a function. X values cannot be repeated in order for it to be a function. So therefore, let's think about what would that look like on a graph. If you were to, let's look at points to begin with. If this x value is paired with only one y value, this x value is paired with only one y, something like this would be a function. However, as soon as this happens, watch this. As soon as this happens, think about this x value right here. If I were to ask you, because this is the x-axis, if I were to ask you, what is this x value paired with? Well, if you go up to the graph, it's paired with this y value, but it's also paired with this y value. If you ever have a point above another point, or the actual vertical line test says, in order to be a function, a vertical line cannot pass through more than one point in the relation. A vertical line right here would actually pass through both of those points. What that means is this x value repeats. Maybe this is 3, and 3 is paired with 2 and with -3 or something like that. But in order to be a function, a vertical line cannot pass through any 2 points on the graph. So therefore, if you're talking about a continuous graph, that was discrete. If you're talking about continuous, this would be a function. Because if you were to draw any vertical lines on this graph, no matter where you draw the vertical lines, look, they're hitting single points on the graph. However, if you were to take something like a circle would not be a function. The reason why, if you draw a vertical line, if any vertical line hits multiple points of your graph, this is not going to be a function. Okay, directions. Let's find domain, range of each relation. Then let's determine if the relation is a function. The domain, again, is a set, so we're going to put it in braces. The set of all x values. So here are my x values, and I'm even going to put them in order. That'd be -1, 0, 4, and 6 would be your domain. Your range is the set of all y values. Let's see, putting them in order, that'd be -9, -5, -2, and +3. Now to see if something is a function or not, let's look at our x values. If there's any x value that repeats, that's paired with more than one y value, then it is not a function. So yes, this would be a function. Number 2, domain is the set of all x values. Your x values are -3, +5. Now you have two different 5s, but you only have to list them once, and 8. There's your domain. The range is going to be -6. I'm putting them in order. All the y values, 0, 2, and 4. However, there's a problem here. If there's any x value that is paired with multiple y values, 5 here as an input is paired with both 2 and -6, this would not be a function. So one way, again, these are all relations. One way that we can write a relation is as a set of ordered pairs, a group of points. Another way we can write relations is as a table. Here you see an XY table. It's very easy to recognize the domain and range from here. Your X's would be -4, 0, 2, and 7 put in order. You don't have to put them in order. I just like to. Your Y values here would be -8, -1, and 3. Now, is this a function? Are there any X values that repeat? There's no X values that repeat, so this would, yes, be a function. Now, a lot of people get confused here because there's a repeating Y value. It does not matter. A good way of thinking about a function, if you were to walk in a store and you've got one item, you pick up an item and you check the price and it has two different price tags on it. That's confusing. You pick up an item and it's got the price is $5 and $10 on it. You don't know what to pay. However, if you walk into the same store, you pick up two different items and both of those items have a $5 price tag on it. It doesn't matter because the Y values, the output values, it doesn't matter if they repeat. The same way, it doesn't matter if the prices repeat. However, if one item has two different prices on it, that's where the problem comes into play. The next one, the domain is the set of all the inputs. We're going to put in our X's. We get 10, 15, 18, and 24 are all of our inputs. Our outputs, set of all outputs would be 0, 3, 7, and 11. And there is definitely no repeats here, so therefore, yes, this would also be a function. A mapping, these are called mappings. A mapping is another way to represent functions. Notice you've got all your x values in this circle, all your y values in this one, or oval, not a circle. Your x values, your domain, would be -4, -2, and 5. All your y values would be your range, which would be 0, 3, 7, and 9. Now, how do we know what is paired with what? Well, here it shows you. The arrows shows you that when your input is -4, your output is 0. So you could actually take this and write it back as a list of points. -2 is paired with 3. 5, there's an issue here. What is 5 paired with? Well, it's actually paired with two different things. 5 is paired with 7 and 5 is paired with 9. This makes it not a function. So anytime you have an x value that's paired with two different y values, that would definitely not be a function. So we're just looking for the arrows here. Domain would be 2, 8, 13, and 17. And your range is going to be the -4, 0, and 7. Now, would this be a function? Take all of your x values, and actually you can ignore your y values here because all we're concerned with is how many different things are each of these paired with. If any of them are paired with two different values, then it's not a function. However, even though both 2 and 13 are paired with 7, each of them have only one arrow. So each of them, 2 has paired with 7, 17 is paired with 7. Again, that's like 2 different items having the same price. That will be fine. That is still, yes, a function. Again, we can also represent relations with graphs. And the rule was, okay, let's do domain and range first, then we'll talk about let's try that again. Your x values, there's a couple of different ways you can do this. You can actually put the points on here. This is -3, 1. This is -3, -2. This is 0, 4. This would be 2, -1. And this would be 4. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, -5. So your x values are -3, 0, 2, and 4. Your y values are, let's see, you can put them in order by starting at the bottom, -5, -2, and then working your way up, -1, 1, and 4. And you have issues, again, anytime there's repeat x's. So we see that these 2 points are going to create an issue. Now, the vertical line test says if you can draw a vertical line and it hits 2 different points, then it's not going to be a function. And you can see why, because if it hits 2 different points, that means those points had to have the same x value, had to have the same input. So is this a function? No, it is not. Now, the other way that you could have actually done your domain and range there, instead of actually listing out all the points, you can just look for what x values you have points. You have points for this x value, for this x value, for this x value, and for this x value, which would again be -3, 0, 2, and 4. Then you have points for which y values. For this y value, again, the y is your vertical axis. So for this one, this one, this one, this one, and this one, which would be again -5, -2, -1, 1, and 4 would be your y values. Now this is a continuous function, so domain and range has worked a little bit different. Domain, think of it like this. If you were to take a vertical line and start moving it from left to right, we want to know where is your graph located. Or if I were to plug this x value in, do I have a point on my graph? Yes. If I plug this x value in, I have graph. I have graph here. I have graph for this x value, for this x value. But however, when does my graph stop? It travels forever to the left. So therefore, I'm going to write this, I believe I'll write it in interval notation. And just to give practice, we'll write it in interval notation and we'll write it in regular notation as well. So for what x values do you have graph? It goes forever to the left and forever to the right. That's all values from -infinity to +infinity. Or you can say the domain, all real numbers. Now, how high and low does your graph go? Now you're thinking about, okay, if you had a line here, where does your graph start here? Okay, you're going to move that line up and say, okay, where does my graph start and where does my graph stop? This line goes down forever. It would actually go below that. So how low would I have to move this line in order to find out where this graph starts? Well, it continues down forever. So therefore, my range is also from -infinity to +infinity. And is also all real numbers. Is it a function? Okay, with a function on a graph, it's super easy. Just draw a bunch of vertical lines. If you can ever hit 2 points, then it is not a function. So therefore, yes, this is going to be a function. Actually, all lines except for vertical lines are functions. Okay, next up. Now this one, domain, is going to be a little bit trickier. Draw you a vertical line, and we're asking ourselves for which x values, where does my graph start on my x-axis? My graph starts right here. Now, what is right here? If you look at your x-axis, this is 0, -1, -2, -3. It starts at -4, and then as you move that line to the right, where does my graph stop? And notice that this arrow continues on forever. So my graph continues forever to the right. So my graph starts at -1, 2, 3. My graph starts at -4 and it goes forever to the right. -4 is a point on my graph. Since it's filled in right here, I am going to include -4. and it goes forever. So that's one way you can write it, from -4 to infinity. Or you can say that x, your domain, your x values are greater than or equal to -4. You can write it either way, just as we did in the last chapter. Now your y values. Your range is simply how high and how low does your graph go. Your range is how far left and how far right does your graph go. My graph goes down forever and it actually goes up forever, so my range would be all real numbers again, or all values from -infinity to +infinity in interval notation. Now, is it a function? If I were to draw a vertical line here, notice what happens. I hit a point here and here. If I were to move over to here and draw a vertical line, I hit a point here and here. If you can draw any vertical lines and hit two different points, this is not a function. Okay, circles. Where does my graph on my x-axis, how far left does my graph go? And how far right does my graph go? My graph is between this x value and this x value. That's how far left and right it goes. So it's between -2 is this x value. It starts at -2 and it stops at 1, 2, 3, 4, 5. So therefore, that's my domain. How far left and right does the graph go? And it goes from -2 up to 5. Now the question is, do I put a parentheses or do I put a bracket? Do I include -2? Do I include 5? Well, if a point is on the graph, actually located on the graph at -2 and 5, then they are included. Now a reminder that we could also write that as an inequality. You could do -2 is less than or equal to x. The reason we use x is because it's the domain, it's all the x's. And then it goes up to 5. So either one of these answers are okay, whether you use interval notation or inequalities. Now your range is how high and low your graph goes. Let's use a different letter or color. This is the lowest point on my graph, and this is the highest point on my graph. So my graph starts, you're talking about y's now, your graph starts here on the y-axis, this is 0, -1, -2, and it goes up to 1, 2, 3, 4. So my range is all values from -2 up to 4, and the same thing, you include it if it's actually a point on the graph, or you could say your range, -2 is less than or equal to y is less than or equal to 4. So y is between -2 and 4. Is it a function? Definitely not, because if you draw a vertical line right there, you will hit 2 points, so that is not a function. Number 11. Relations can also be written as equations. And there's a couple of different ways you can actually work these that have equations. Okay, now your question is your domain. What all can I put here? Is there any restrictions on what x can be? Now, some things that have restrictions. Let's discuss this, and we'll talk more about this as the year goes on. If there's an x on the bottom of a fraction, you cannot divide by 0. That's illegal in math. So anytime that you're sticking x in there that's going to force you to divide by 0, that can't be part of the domain. Some other things that you can't do. You can't take the square root of a negative and it give you a real number. So if x here were like a -1 or a -2 or even -0.01, then that's going to be illegal. So that would be a domain restriction. But other than that, we'll talk about some logarithms and stuff like that, some tangent functions later that will have different restrictions. But other than that, you can put anything in that you want to. Can x right here, can I put a -1 million? Well, couldn't you square it and make it negative and add 3 to it? Sure. In this case, you can put in anything in your graph that you want to, or in your function. So x can be anything. Now, the next question is, what would you get? If you put these values in, what would your y values be? And you could actually test this by plugging in. You could plug in -3, -4, -5, 0. And let me show you what actually happens. -x squared plus 3, when you start plugging in some values, you could look at a table, and you could actually make you a table and plug some in, plug in a -2, -1, 0, 1, and 2. And here's what you would get. And I noticed something, that the values start repeating. And then something special happens here. Look at your y values. Your y values are -1 and then goes up some more and then goes up some more and then it starts going back down. Your y values, and you can plug in even more, your y values never get above 3. Now, if you were to plug in like -3, -4, -5, they get lower and lower and lower, but they never get above 3. So you can plug those in and you'll find out again that your Y values go down forever. However, the highest that they ever get is 3. So that's one way of working it is with tables. However, another way and probably the easiest way, why not just graph it? Desmos, you can go to desmos.com, a really nice graphing calculator, and that's what I've done here. I've graphed it and you see the exact same thing. You have what's called a parabola here, and notice how far down it goes. It goes down forever. What about left and right? Could I draw a line to the left of this graph and a line to the right? Well, if I were to draw a line here, it's going to hit the graph, and you notice it tapers out forever. So pick an x value. If I picked an x value of -20, is that x value on your graph? Well, if you were to plug in -20 right here, -20 squared and then take the negative, add 3, yeah, you can plug that in. So there's a point on your graph that goes along with -20. So therefore this graph goes forever left and right. It does not stop. However, look at your range. Look at your uppers and lowers. The highest that your graph ever gets is right here. It never gets any taller anywhere above, look at that Y value, 3. So therefore, that's another way of seeing your range is the highest point on your graph is 3, and that's what we did here. Your range goes from -infinity to 3. Now, is it a function? And you can see very easily from the graph that it would be a function, yes, because of the vertical line test. Or you could say, is there any way that these x values could repeat? Or if I plug in -2, could I get 2 different y values? And you're not going to. Number 12, domain. What can x be? You can plug in anything, and we'll look at the graph of this as well in just a second. Hopefully you already know what the graph looks like. Now the range, what would you get? Now let's plug in some values. If you plug in, you can make yourself a table, plug in -2, plug in -1, plug in 0, 1, 2, and you'll see what starts to happen. However, these are much easier to solve by looking at graphs. This is a linear equation. This linear equation, if you remember slope-intercept, y equals mx plus b, has a y-intercept of -1, has a slope of -5. This line looks something like this. So it goes left and right forever. Well, how far up and down does it go? It goes up forever and it goes down forever. So the range will also be negative to positive infinity. Is it a function? Could you draw vertical lines and hit more than one point? And you cannot. So therefore, yes, this is going to be a function. Again, the only line that is not a function is a vertical line. Y equals -7. So your domain, what can x be? Can x be 3? Sure. Well, what is y when x is 3? This says that no matter what x is, y is -7. There's nowhere to plug in an x. However, x can be 3, 4, 5. X can be anything you want it to be. What if x were -1 million? What is y? -7. What if x is 2? What is y? -7. X can be anything you want it to. However, the range has only a single value. And I'm going to list that single value right there. The only thing that y can be is -7. So what would this graph look like? If you don't remember, if x is, let's draw this, if x is 1, y is -7. If x is 2, y is -7. If x is 0, y is -7. If x is -1, y is -7. This is a horizontal line. The y values on this line is only -7. However, the x values extends forever to the left and forever to the right. Is it a function? Check with vertical lines. And yes, this would be a function. Now the next one, x equals -1. If you don't remember this one, x equals -1 is actually a vertical line. Looks like this. So what is your domain? There's only one element in your domain, and that is -1. What is your range? How high does your graph go and how low does your graph go? Forever and forever. So therefore, what would a table, think about this, what would a table of this look like? Well, what if x is -1? Well, y could be 2, y could be 3, y could be 4, y could be 5. And look at all the repeats. -1's paired with 2, -1's paired with 3, -1's paired with 4. So this is definitely not a function. Why? Because if you were to draw a vertical line right here, you actually hit every point on this graph.